Hey guys, how's it going? I hope you're all well. I am going to be teaching you today 4.1. Although you've already seen an ed puzzle on it, I figured I'm going to teach it the way I would have had we been in the classroom. And so you're going to see 4.1 from me, and tomorrow you'll see 4.2, and eventually we'll get to 4.3 before your next test. So here we go. So here's the page 232. You had this for your assignment last week. I'm going to be looking first at number 6. Number 6 says y equals 3 to the x power. And this is what exponential growth pretty much looks like. How do I know that this is exponential growth? Because this number, your b, okay, your base, is a number that's greater than 1. Okay, so when this number is greater than 1, we automatically know that your graph is going to be growing. And a growth function will always look like a j. Okay, it's going to be a j graph, meaning it's going to start low. Okay, and see, it's going to start low, and then it's going to go up high. Okay, so let's look at this example. How do we do it? So basically, we just make a table, XY table. And obviously, you guys have a lot of resources at home. You have Desmos. Some of you may have graphing calculators, whatever else you may have at home. But really, we don't need any of that. We just need to make a table of values. Pick easy numbers, okay? So -2, -1, 0, 1, and 2. That's usually the numbers you want to go with. You plug them in one by one. Negatives can be a little tricky, so let me just remind you how that works. 3 to the -2. So what would I do? Basically, I want to put this 3 over 1. I'm going to flip this guy because it's negative. So that would be 1 over 3 squared, which is 1 over 9. So 1/9. Doing the same thing for -1, you'll result in 1 over 3. For 0, anything to the 0 power is always 1. And then the positives, hopefully, that's pretty simple, right? 3 to the first power is just 3. And 3 to the second power is 9. Okay? Let me just take this out of the way for a second. Okay. So, as you can see, it's growing. The numbers start at 1/9 and end at 9. So they grow. So now we basically just make this into a graph using this lovely graph paper here that I have. Okay, so now I plot my points. -2, 1/9 would be at the -2 right here on the x. 1/9 is just a number that's slightly above 0, so right here. Then we have -1, 1/3, so -1 and then 1/3 is a little higher. 0, 1 is right here, and 1, 3 is here, and 2, 9 is 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. We connect our graph, and now we got to be really careful here because your numbers don't go below the x-axis and they don't touch the x-axis. The x-axis is actually our asymptote, okay? An asymptote is basically a line that your graph gets very close to but does not touch or cross. So now we connect these. We just got to be careful we don't hit the x-axis. And there we go. Okay, that's a growth function. And again, all growth functions are going to look like j's. Now, problems can get more complicated, obviously, as you saw from your classwork. So let's say that there was a number in front. Okay, so let's say the number, let me make some space here. Hold on. Okay, so let me just change this problem for a second. Let's say there had been a number in front. So let's say it was like 2 times this, okay? So had that happen, basically The only difference is, the only extra step you would have had to do there is all of these numbers. Hold on, let me use a different color. Let me use red here. Okay, so all of these numbers that you already have would have just been multiplied by 2, each one. Okay, that's the only difference. If there's a number in front of your equation, that's what you have to do. Okay, now let's add more to the problem. So now let's say that there was like I'm going to say a plus, I don't know, plus 2 next to your x, okay? So if the number is with the x in the exponent, you're going to basically take the opposite sign of it. So what's the opposite sign of plus 2? Minus 2, right? So we're going to do that to the x value, so minus 2. And that would be how you would do something like that. Okay, so all your numbers in the x would just get subtracted by 2. All right, so what would that be? So let's do that. Okay, so our y values would stay the same. And that would be negative 2 minus 2, that's negative 4. Negative 1 minus 2, that's negative 3. 0 minus 2 is negative 2. 1 minus 2, negative 1. And 2 minus 2, 0. Okay? So all your x values would get subtracted by 2, otherwise also known as shifting 2 spaces to the left. Okay? Now let's take it another step further. And really this is the most complicated it's going to get. Okay? Let's say, I'm going to just erase all this because it's going to get more and more confusing. You know what? Let's just do an entirely new problem so we don't keep adding to this same one here. All right. Let's do another one from the book. And this will be our last example. Okay, let's look at something like number 16 actually, because number 16 was another problem you had to do for the classwork last week. So 16 says y equals 5 times 4 to the x power and then plus 2. Now what I want you to notice is that this plus 2 comes after the x. It's not with the x, okay? Notice it's after. It's not an exponent. So that's how you know here that this number is not going to get used for the x's. It's going to get used for the y's instead. So again, how do we start? We start by making a table of values. Okay, always use the same numbers because they're easy. Negative 2, negative 1, 0, 1, and 2. Okay, this number here, this plus 2, we're going to do at the last step. Okay, so for now, let's just do the beginning. Let's just do 5 times 4 to the x power, get those answers here, and then we'll add 2 to them so it's easier that way. Okay, just like we did for the radical equations. So let's start with negative 2. We would do 5 times 4 to the negative 2. Do the exponent first, so 4 to the negative 2 power is the same thing as saying 1 over 4 squared, which is 1 over 16. So then 5 times 1 over 16 is just 5 over 16. And you can do that as a decimal if you want. Okay, so 5 over 16. Let's see here, what would that be? My calculator. 5 over 16 is 0.31 approximately. Okay, so if you feel more comfortable working with decimals, we could just change that right here to 0.31. All right. Now let's do negative 1. So you try it as I'm trying it, because if the more you practice, the better you'll get. Okay. So 5 times 4 to the negative 1 is the same thing as saying 5 times 1/4, which is 5 over 4. And as a decimal, that would be about 1.25. Okay, so we put that in our table of values. Now the 0, again, 0 power. Anything to the 0 power is just 1. So when we plug in the 0, that 4 is going to turn into a 1. So that's 5 times 1, which is just 5. Okay? Then the positive powers hopefully are easy for you. 4 to the first power is 4, and 4 times 5 is 20. Okay? Then the second power, 4 to the second power is 16. Okay? And 16 times 5 is 80. Okay? So the numbers get really large. So notice here for 20 and 80, we're going to have to make our graph skip by possibly tens. I would say tens is fine. Okay. So now we have to do our shift. Our shift says we're going to be moving up 2 spaces on the Y. That's our vertical shift. Okay. So we're going to add 2 to all of these numbers, and that's going to be our final table. Okay. So that would be, and here the x's stay the same because there's no number next to the x in the exponent. Okay. So let's add 2 to everything. I'm going to be lazy and just do this here. Okay, so that's going to become a 7. This is going to become 3.25. This is going to become 2.31. And this is going to become 22 and 82. Okay. There you go. And that's what we're going to plot. So when we plot that, let's make a graph. I know this is very sloppy. Work with me here. Okay. So negative 2, 2.31 is right here. Negative 1, oh no, sorry. My mistake. I'm going to go up by tens, right? So if we're going to go up by tens on our graph, I'm going to go like this. 10, this is 20, 30, 40. You might hear my daughter in the background, sorry. All right. Here we go. Now we're in business. Okay. So negative 2, 2.31 is very close here. Negative 1, 3.25, let's just say there. 0, 7 is there. 122 is here. And 282 is all the way up there. And there we go. Bam. Okay. Now, for our domain and range, okay, we haven't talked about that yet. Domain is, again, what number can you plug in for x? Well, any number, because what we're doing is we're plugging in just random numbers for x. So domain is always going to be all real numbers, okay? Now, your range is tricky. Range, we're talking about y values, okay? So our y values are normally just positive numbers, all numbers greater than 0, okay? But here, because we added 2, and in general, whatever you add or whatever this extra number is here, that's always how you're going to do your range. So you're always going to say y is greater than that number. So y is greater than 2. Okay, if it were negative 2, we would say y is greater than negative 2. Whatever that number is, that's what your range is always going to be. And that's also what your asymptote is. Again, what's an asymptote? An asymptote is a line that your graph gets very close to but doesn't touch or cross. Don't worry about asymptote. Just worry about, really, when I ask you for domain and range, if there was no number there, you would say y greater than 0. Okay, but since there's a number here, we're always going to say y is greater than whatever that number is. Okay? Now, can it get more complicated if there's a negative in front and things like that? Yes, but we're virtually learning, so we're not going to try to trick you here. That's pretty much what you're going to get for this section. Okay, please replay the video if you're confused on anything. I'll be hosting Zoom meetings as well, so you can ask me live, you can ask me questions, but definitely take this down in your notebook. You will be tested on it later, including 4.2 and 4.3. And tomorrow you'll be seeing a video of 4.2, which is exponential decay, which just means that the graph is going to go from high to low instead of low to high like these do. Okay? Hope this clears up some questions. I'll talk to you guys soon.